guys, this is Jashwant and this is my Mlops project on time series regression using bike sharing dataset. So the goal of this project is to build an end-to-end MLOps pipeline including data pre-processing, model training, equipment tracking and model registry and also API deployment. And so for the initially I have taken the dataset from a publicly available server which is a bike sharing dataset and it consists of around 10,000 records, and this is the raw dataset which I have taken from the source. And by using some of the data cleaning techniques using Excel, I have changed this data into a clean dataset which looks like the following way. So data cleaning includes handling timestamps, validating numerical ranges and ensuring consistency across the features. We validate the cleaning process using df describe function before and after the cleaning. And after the dataset and cleaning process, we comes into a time-based splitting technique in which to prevent the data leakage, we apply a strict chronological split. Such as for that, we have used one of the following code in which the first 35% of the timeline was used for training and the next 35% for validation and the final 30% for the testing. As we can see here, we are using the trial and init total rows into 0.35 and the remaining into 0.70, and we are printing as per the following regulations by 35%, 35% and 30%. And after the time based splitting, we here it comes the H2O auto ML. We used H2O auto ML on training data on automatically evaluate multiple algorithms, so which we can see here. With this, the top performing models were stacked assembles, which indicates that tree-based models such as random forest, XGBoost, and gradient boosting were the strongest candidates. So here we can and also the top three models in this screenshot we observe the top three models and the RSM, MSE, and the mean residential deviance. So by using this H2O AutoML, we are grading the athletes depending on their performance and endurance. So which helps us to track their progress and help them to evolve their performances.
Hi, this is Madhu. I'll explain my contribution in the project. I manually trained the three models, random forest, XZ boost and gradient boosting. Each model was trained using the same engineered features extracted from the data line. You can check the coding part here. All experiments were logged into a remote workflow tracking server running on AWS EC2 using the Neon Poster Give SQL as the backend store and S3 as the artifact store. And all three models were registered in the MLflow model registry under a single model name with the multiple versions. Based on the RMSE comparison, gradient boosting achieved the lowest error and it was selected as the champion model. You can see all the screenshots here. And we deployed the champion model using the fast API. The API loads the model from the ML flow and exposes the prediction endpoints. The Swagger UI allows the user to submit the JSON input and receive the predictions along with the metadata such as the model name and version like that. And all three models were registered in the MLflow model registry under a single model name with the multiple versions. Based on the RMSE comparison, gradient boosting achieved the lowest error and it was selected as the champion model. You can see all the screenshots here. And we deployed the champion model using the fast API. The API loads the model from the ML flow and the exposes the prediction endpoints. The Swagger UI allows the user to submit the JSON input and receive the predictions along with the metadata such as the model name and version like that.
Hi, my name is Hemant. So, in this, I have used Nanny ML to detect data drift by comparing the training data with newer production like data. So, here, drift was measured using Jensen Shannon distance across time based chunks. Since all values stayed below the alert thresholds, no drift was detected, indicating that this feature was stable among the distributions. So here the screenshots clearly shows that a drift based output and also a summary data plot also shows the same. So to conclude, this project demonstrates a complete MLO piece lifecycle from data ingestion to monitoring. It also highlights reproducibility, scalability, and real world deployment considerations. Thank you.